In this episode of Hot Hardware's 2.5 Geeks, we're going to get all 3D with the V-Cache and a very special guest from AMD. Next. Welcome back, ladies and gentlemen, brothers and sisters, to another fine episode of Hot Hardware's 2.5 Geeks live stream, coming to you from the Nordic country here in the New England area. I've got Marco with me, as always. How are you doing, brother, in Connecticut?
I'm doing okay, dealing with a little snow today, but can't really complain.
Yeah, Chris is in Kentucky, Chris, and there's no snow down there, I don't think.
Nope, not for me.
Says the mild man behind the mixing board. But with us is another mild man and a very smart guy, important guy from AMD, a gentleman by the name of David McAfee. He is corporate VP and general manager at Client Channel Business. Do I have that right, David?
That's right. Good to see you guys. How you doing?
Good to have you with us. Good to see you as well. Yes, it is the day of shipment for 3D V-Cache 7000 series processors from AMD, and we figured we'd have you on to talk a little shop with you. Marco's met you before. This is the first time I've actually met you face to face, and
indeed, no, it's a very exciting day for us. Glad to be here with you guys, and yeah, hopefully we can talk a little bit about X3D and what's going on with our AM5 platform in general.
Absolutely. And yeah, and to the audience, folks, certainly feel free to fire your questions into the chat. We will try and field those that we can. We will try not to get David in trouble. He likes his job, and is very good at it. So we're going to keep it that way. And but we're going to pepper him with some tough questions along the way for sure, and try and answer your burning questions and our burning questions on this interesting and powerful new tech from AMD that's really juicing up gaming systems around the globe, it seems now, selling like hotcakes too. But Dave, let's start with you first. Sure. Let's talk about where you came from, your background. I know you've been with AMD for quite a few years, fairly new to your role as general manager and corporate VP of the Client Channel Business Group. Yeah, just a little bit about your bailiwick and what you do there at AMD.
Yeah, sure. No, happy to. I joined AMD in 2006. It's been, gosh, over 15 years now, which is really hard to believe. But over the years at AMD, I've spent all of my time in the client business. So that's notebooks and desktop processors until very recently, and actually still today, I lead all of our roadmap planning for all of our desktop and mobile products as well. And so transition from that to running our desktop business for our Ryzen processors. And it's actually, over the past year, I've learned so much. It's been a really exciting change and an amazing change in my career to get the opportunity to not just have a hand in developing and defining the products, but also seeing how those products come to life in customers' hands, getting to work with all the partners, our ecosystem partners in Taiwan, our memory partners, bringing all the pieces together. And I think that's really maybe the most exciting part of the job for me is getting to, kind of have my hands on all those pieces, put them together and bring the great Ryzen platforms together.
Pretty cool. And actually, yeah, you mentioned a lot of hats that you wear there. What would be your favorite? I heard you mention roadmap definition and whatnot. What would be the thing you like to do most, I guess, maybe?
Yeah, no, that's a hard one to answer, honestly, because each one has its own things that, kind of get you out of bed at the morning and get you excited about the job. I think it's at a company like AMD, that has been one of the best things about being here is you're surrounded by so many talented engineers, and to have the opportunity to help shape not just the roadmap, but really where the future of computing is going. And that job of defining the roadmap, you're thinking 3 or 5 years out into the future about what's the world going to need in a computing device, in a notebook, in a desktop, in all these different segments that Ryzen processors go into. And so it really is a lot of fun, both working with customers and OS partners and our architects and designers at AMD to understand where the future is going to take us and how we fit into that future of computing, building leadership products for the future. So that part has really, it's very close to my heart. It's something I love doing. But by the same token, like I said, getting really close to, not just shaping the future, but getting hands-on with products, working with our partners, building motherboards in Taiwan, seeing that all come together with the community of Ryzen enthusiasts has been absolutely amazing as well. I mean, I think that, each and every day I go out and kind of read what's happening in the communities, in the forums, Reddit and other places on what people are saying about AMD processors and Ryzen, to really stay close to how the sentiment is around our products. And I'm really fortunate to be in a part of the business where there's so many people that are passionate about what we build, so many people that share as much excitement and get as much enjoyment out of the products that we're working on. That really is something that I feed off of and brings me a lot of energy to what I do every day.
Nice. Yeah, no, absolutely. And certainly you folks have done a great job about listening to the audience, and being accessible to the audience. So kudos for that, for sure. Yeah, you guys have a good setup for that. And that's always good to get engagement with the audience, to get input from the folks you're, catering to, obviously. So that's good stuff. Marco, you're gonna draft in the questions from the audience. You've got a few on your plate. I've got a few. I know Chris even tossed in a couple. But let's go around the horn a little bit. Are you going to keep a look on the chat for us, right?
Yeah, I'll try to squeeze the chat questions in like as it's relevant to the conversation. I think we'll start with the product at hand today before we go to some of the questions that were more general or about other platforms, perhaps.
Yeah.
So let's start with the simple one, because there's one big difference with this platform, obviously over and above the 3D V-Cache.
Yep.
Something that differentiates this launch is that you guys launched a special chipset driver that's sort of required to get optimal performance out of the platform. Could you explain, why that is and what the driver does and how it optimizes performance for these new processors?
Sure. And I think, we launched our first 3D V-Cache product in our 5000 series last year, the 5800X3D. And I think, kind of the amazing thing about that product was the gaming performance improvement that it brought, but it also had some sacrifices that came along with it. The single core frequency was a little bit lower. You saw lower benchmark scores on that product as well. And so it was a product that was perfectly suited for a great gaming experience, but if you were looking for an all-around processor, it did have some trade-offs that went along with it. When we launched our Ryzen 9 7000 series 3D V-Cache processors, like our 5950X3D and our 7950X3D and our 7900 X3D, what we've done is we've taken an asymmetric approach to the two CCDs on the chip. And you can kind of see it in that picture that we were looking at a moment ago. You can barely see it, actually. Yeah, there you go. There's the outline of the 3D stack cache on top of one of the core chiplets. The other core chiplet does not have stack cache on top. And what that allows the processor to do is have one chiplet that is outstanding for games that are sensitive to factors like memory latency, which the cache does an amazing job of reducing and accelerating the gameplay experience on the product. The other non-stack die allows you to run at the maximum single core frequency. And so you kind of get the best of both worlds between those two chiplets on the product. Now, what that chipset driver does, what the things like the game bar in Windows does, is allows the operating system and the processor to communicate with each other, handshake with each other, so that basically we can steer the right applications to the right core chiplet in the product. When it's a game that we know is very sensitive to memory latency or improves significantly with cache, we can steer that title to the stacked CCD. When it's something that really doesn't require that, or it's not a game, a productivity application where really the application benefits more from just raw single thread performance or single core frequency, we steer that to the non-stack CCD. And so the combination of that awareness in the OS as communicated through the chipset driver is what connects that chain and links everything together and allows us to kind of give the best of both worlds. Whether you want a gaming processor, whether you want something that's for pure productivity or single thread performance, it's really delivering on both fronts. And that was a problem that we really saw in that first generation of X3D processors. been working for quite some time, since we launched, actually since before we launched our 5000 series X3D processors, on cracking the ability to deliver kind of on both ends of that spectrum. And today you're seeing the fruits of all of that effort.
Nice.
Awesome. Yeah. Oh, go ahead, Dave. Sorry.
Yeah, no, I was just gonna ask. I mean, obviously, there's some pretty advanced technology there, stacking, cache on top of the die. What were some of the challenges of getting a cutting edge product like that out the door? Packaging, yield, sort of all the above, probably. I imagine it's a fairly complex, technology to pull together, and I just understand the challenges of that and making that come to fruition.
It's an incredibly advanced technology, and I'm not going to pretend to explain all of the wizardry that goes into how that actually comes together. But I will say, we've worked very closely with TSMC on now a couple of generations of 3D stack cache technology. They have been an absolutely outstanding partner in working through those issues, helping to make sure that as we stack cache on top of die, that it's a process that's very reliable, provides very robust yield as well. And the combination of, the two CCDs, one stacked, one non-stacked, gives us the opportunity to put a lot of flexibility into the product. Now, kind of flipping to the other side of that, what challenges does it bring? What limitations does it bring? I think we've now seen that in 2 generations. There are limitations when you stack cache on top of a processor about what you can do with, let's call it, totally free voltage and frequency control in an overclocked processor. Even in this generation, while there are more overclocking capabilities that go into the 7000X X3D processors, there are still limitations. And so ensuring that we put, the right parameters around what we can allow a user to do with that processor to keep it operating in a safe reliability limit is, just some of the things that we have to work through. And that, again, is something, as we look through our testing, as we work with our foundry partners and TSMC to understand how that process affects the characteristics of the silicon, that's something that, we've definitely spent a lot of time on to make sure we're really delivering a product that's going to live up to what somebody wants to do with it for years to come.
Nice. Makes sense. Good stuff.
So I actually have a follow-up to the software question, but
Absolutely.
a follow-up to Dave's question as well. So I'm just going to pop something up on the screen because it's sort of relevant to what I'm going to ask. Now, since this is sort of, your first swag at the 3D Vcache optimized driver, can we assume or expect that perhaps in the future there are other things you guys can do via software to optimize the performance of the chips? And to ease sort of the experience for customers, is it possible that driver gets incorporated into, say, Windows Update for, say, less savvy people putting together their first rig, they don't know to install the chipset driver?
No, that's a really great question. Great suggestion as well about pushing the update through, or pushing the driver through Windows Update. Our relationship with Microsoft is really close. We've used the Windows Update mechanism to push updates to our Radeon drivers. We've done it with chipset drivers in the past as well. I think you can assume that as we get further along with this technology, that's definitely a technique that we'll use to make sure that users are getting the right experience out of the box, and that they really don't have to go through those extra steps of finding and downloading and installing another package. Windows just recognizes it and it works right out of the box. And I think the other thing that's a part of the mechanism that we've used, chipset driver combined with the game bar in Windows, is it is kind of a learning mechanism as well, right? As time goes on, as new games are developed, that list of games that's supported in the game bar application, or maybe supported is the wrong word, detected through the game bar application or the game bar service, is constantly updated by the Microsoft team as new games come into the Windows ecosystem. And so it's not a static capability, it's a capability that adapts and evolves and gets better and better over time. And so, those 2 things put together, I think, really gives me a lot of confidence that as time goes on, we can make that a better and more seamless experience for a user.
Awesome. Great. And then now following up on the silicon question, something that sort of, you may not be able to provide much detail here, but you can't just bolt 3D Vcache onto any old die, right?
No.
And you guys did it with 5000 series, did it with, 7000 series. Now, can you give any sort of color as to how early AMD was planning to use 3D V-Cache and what sort of accommodations you guys had to make when designing Zen 3 and Zen 4 to sort of pull this off?
Yeah, that's a really good question. I mean, it is a development for 5000 or 7000 series that goes back several years, and the planning for how that cache stacks directly on top of the natural cache zone or cache region that's on the core chiplet is critically important. It actually is different processing that's done on the base core chiplet when 3D cache gets stacked on top of it, so that you have all of the right connections through the die, so that you're getting the copper to copper bonding that really is what delivers that incredible performance, and to the chip or to the system makes it appear as one contiguous block of cache that allows for that acceleration in the game. So it is a unique process flow that core chiplet goes through. It's unique processing even after manufacturing that readies it for the 3D stacking process to occur on top of it. If you look at it from the overall timeline, it is a very lengthy process, both in design as well as in manufacturing, where the cycle time to build X3D products is significantly longer than what it takes to process normal core chiplets or normal silicon to put into a desktop processor. So there's a really non-trivial investment there in planning and time and in co-development that has to happen to make that all come together.
And speaking of planning and time, just on this same vein,
Yep.
there has to be sort of a cutoff point or a point of diminishing returns with cache size. Have you guys simulated or sort of experimented with even larger caches and how it could perhaps affect performance?
Yeah, that's a good question as well. And I think that as we look at what we've done with 3D Stack Cache in our products, and honestly, it's a technology that spans across AMD's product portfolio. There are products in the EPYC server product line as well that use 3D Stack Cache technology, and it is highly workload dependent. In that EPYC domain, what you see is HPC type applications that have massive data sets, show an affinity and a performance improvement that goes along with stack cache. In the client domain, oddly enough, it's not highly scientific applications. It's games that love it, right? Because games love low memory latency, and low memory latency or effective low memory latency comes with having this really large block of cache very close to the processor itself. When you look at the breakpoints of a non-stacked CCD where you've got 32 megabytes of cache per CCD, and you're putting additional cache on top of that, we've done experiments to look at various sizes of cache that might go on top of it. But again, it's about finding a solution that can be leveraged across AMD's entire product portfolio. So I think it's totally fair to say that there are a lot of games where an additional 32 megs of cache in the stack cache would be just fine with that amount of cache, and you'd still see 99% of the performance uplift that you see with the 64 meg additional cache that's in our 7000 series products today. But because that spans a wide range of games as well as a wide range of business lines within AMD, that 64 megs of stack cache is really the right answer to fill so many different needs that one design has to fill.
Got it. I had a question actually following up on that, and that makes a lot of sense, David. Thanks. You talked about longer cycle times out of the fab. These chips are obviously they're already selling like hotcakes. We're finding out that they're pretty much sold out at retailers on day one here, from what we've seen, which,
Thanks everybody for that. I really appreciate it.
I'm sure you guys are happy about that, right? Yeah. What sorts of strategies can you folks employ, or are you employing to ensure, as much of a supply, as you can for gamers and enthusiasts on these chips?
No, we've been through some pretty dynamic times over the past couple of years with supply, and I think through COVID and all of the challenges that existed over the past couple of years, there is a lot more sensitivity to planning and making sure that we have enough supply of our products as they go into market to satisfy the demand that's out there. What I will say is we have an enormous amount of supply that is stacked up behind these initial products or this initial launch volume that's come to market, planned through this quarter as well as through the rest of the year. I think for quite some time, we've known that the gaming performance of these products is going to be as good as what we saw in the reviews yesterday, and as good as what people are going to see when they get these products in their hands. In fact, I would even say it's a little bit better than what we originally expected when we started projecting the gaming performance uplift we would see on these products. But we expected a very strong reaction from the market. We've got lots of supply planned to meet that anticipated demand that we expect to see over the next several months and quarters. And honestly, at this point in the overall manufacturing of chips and substrates and everything else, there are very few things, if anything, that's holding us back from building more. Which is really why we've put these aggressive plans in place to help grow this X3D adoption, get it in more people's hands, and for the gamers who want to have the best gaming experience that we can, make sure that they can find those products very easily.
Amen. Good stuff. Yeah, and actually, one more question, Marco, and then I swear I'll give you back the reins.
No, all good, all good.
No, I just on that note, you talked about how the performance may even be exceeding what you were initially targeted. Loaded question: are you happy with the launch of Ryzen 7000X3D so far?
I'm thrilled. I mean, honestly, the reviews that I've read, the things that I've seen, I think there's two things that make me really happy. One is the gaming performance that we were hoping reviewers to find when they looked at the performance of this chip across a range of titles came through loud and clear. It is a fantastic gaming product, and the leadership of this product really kind of shone through in many of those reviews. The other thing that I'm really excited about is the power efficiency of this product, of our 7000 series products in general, came through as well. And I think that this combination of using things like our Vcache technology to really provide much better gaming performance at much lower power is a really interesting capability that AMD has. Really interesting way to kind of change the game in terms of what we can deliver in terms of performance per watt for these types of products.
Excellent. Yeah, good stuff.
So that's a perfect segue for one of the questions that we had.
Yeah.
One of the things that we noticed. Yeah. So the graph is up on the screen there now. The 7950X3D under full load. It effectively, now this is with the multi-threaded rendering workload, so all the cache wasn't lit up, but almost half of 13900 KS, not quite half, but it's a stark difference and a huge reduction over the regular 7950X. Can you explain? Now you would think power is going to go up with all that extra cache, but with that CCD operating at somewhat lower frequencies and voltages, were you guys expecting this stark of a difference? Can you just provide some color on that?
Yeah, no, I think that we absolutely anticipated that this would have superior power efficiency, and that's you mentioned frequency and voltage. It is one of the reasons why the 7950X3D and the 7900X3D are 125 watt TDP parts. We talked about some of those factors a few minutes ago about let's call it the limitations or characteristics of 3D stacking and what that does to product definition. Well, one of those factors is we're not able to raise the voltage as much as we are on a non-stacked product, and so that in turn leads to lower frequency, which leads to lower power. And so that really 125 watt threshold on this product, given some of the characteristics of the stacked CCD in the product, really led us to a point where you saw that above 125 watts, there really wasn't any performance benefit that the user got out of that. That's also the difference why our non-stacked 7950X is a little bit higher power product, because we are able to juice up voltage a little bit, and we are able to deliver more performance to more power to the end user. But with the 3D stack cache, 125 watts was really kind of the asymptote that we saw in that power performance curve, and it kind of led to the sweet spot of, hey, really efficient operating point, gives us most of the performance that you can get out of that 7950X non-stacked part, but does it much more efficiently as well.
Got it. Awesome. I think I'm gonna throw a couple of questions from the chat in, just because they're scrolling by and I'm gonna miss them. You probably can't answer many of these, but we're gonna take a shot anyway. If you can't, no sweat. So regular viewer Steez is asking if we could expect 3D V-Cache to maybe make it into laptops with a Dragon range. Is that something AMD's exploring?
So I cannot comment on future products, but what I will say is, Dragon Range product we announced at CES. If you look very closely at that product, what it really does is take our 7000 series desktop processors, move it into a BGA package for those extreme gaming and creator notebooks. I think that we are in the infancy of what that product family can do. We're in the infancy of what our OEM designs and the creativity of those systems will enable. And so I'd say, let's wait and see how that product family evolves. I think we have internally a lot of excitement when we look at, where that family can go, and we'll see what the future holds.
Okay, great. And we're going to go to the past for a second here. The question came in really early. Given how well the 5800X3D sold and the huge install base of AM4, is there any possibility of future AM4 processors with 3D V-Cache?
No, a good question as well. I think our AM4 family of processors, we've been really pleasantly surprised over Q4 in particular by how much the velocity of the sales of the 5800X3D picked up. That was an interesting product where when we first launched it, the nuance of lower frequency, lower benchmark scores, yet really great gaming, it took a while for that product to take hold and really pick up in market. Now we've really seen that product kind of hit its stride, and it's got a great following. It's got a great fan base that goes along with it as well. I don't anticipate that we're going to be introducing more X3D products in the 5000 series family. But I will say that it really is a product that has gotten a lot of momentum. We're constantly having active discussions about how our AM4 product family evolves, because I think we see it as a great part of the AMD portfolio. With 7000 series and 5000 series, you really have both a forward-looking end generation platform and an N-1 platform that complement each other very nicely, address different segments and price points in the market, and give gamers and end users a lot of options for what they choose when they build an AMD system. So it's a conversation we're continuously having, because I expect AM4 to continue into the future for a number of years. It's a very viable platform for sure.
Yeah, definitely. So I forget which one of our articles it was, but I saw a comment actually that the 5800X3D was so good that he's not considering one of the new ones, unfortunately. Yep. But yeah, at the price and the performance it offered, the 5800X3D is just awesome processor.
It's a great part.
Yep. So one of the differences between that part and these are with the 7000X3Ds, you're now offering some limited overclocking, so you can use your core optimizer and precision boost overdrive. Can you explain why that is, and how those features can sort of work with this generation, whereas they wouldn't with the previous?
Sure. No, it's I'll say first and foremost, it is our continuous engineering and involvement of how we can make those products better. I know that when we launched that 5800X3D, there was a lot of feedback from the community that they wanted more overclocking features and they wanted more overclocking capabilities on that part. And while we can't necessarily make it as flexible as what you see on a regular non-stacked part, we definitely wanted to continue providing more features and capabilities for overclocking for enthusiasts who want an X3D part in their AM5 build. And so those aren't necessarily capabilities that we can port backwards. Those are things that we specifically engineered as we were going through the process of developing and qualifying and building those 7000 series X3D parts. But man, it's an effort to just continually make the product family better and better and provide more capability as we introduce each new generation of X3D products. So definitely trying to listen to the community and respond to the feedback that we're getting as we hear their frustrations or limitations with what we have in our product family at any point in time.
Gotcha. Totally understood. Dave, your turn, or you want me to keep going?
No, go for it, man. Go for it. I've got one kind of in the back burner here, literally, but go for it.
All right. So, the 3D cache technology shows obvious benefits. We see it in the benchmarks. It's, clearly there's a stark benefit for gamers, especially, on the desktop systems. But there's a point where, well, let me phrase this differently. There's a cost involved and there's complexity involved to implement 3D vcache.
Mm-hmm.
And I'm wondering if you guys have explored, or there's a reason why you wouldn't say perhaps use larger L1 and L2 caches and, a larger traditional L3 cache without having to employ specialized manufacturing processes. Was there a point where you guys decided 3D vcache just makes more sense than going with a larger die for the CPU itself?
Yeah, I think there's a couple of reasons for that, quite honestly. Maybe I'll start with the simplest, and that is, with any processor, fitting it onto, and I got some props here, so there you go. You go back to the product itself, and you look at the physical space that's available on the AM5 package. Going to a much larger core chiplet, might not fit under the lid, might not allow you to do the things that you want to do with a larger L2, L3 cache structure that gives you the same benefit of X3D. And so one really unique way to solve that is to go vertical as opposed to spreading out more in the X and Y direction. You can see in this picture, there's a lot of silicon packed onto that die. And when you think about, the clearance for the lid that has to fit on top of that, there's not necessarily a lot of extra room to grow those core chiplets dramatically with significantly larger caches that would give you the same benefit. I think the other part of that answer, Marco, is, if you look at it, there are specific workloads that X3D technology or the vcache technology benefits very specifically, and that's gaming. But I think we also recognize that our AM5 processors go into many, many different workloads, many different verticals. They're used in commercial settings. They're used by creators and content developers. They're used in all sorts of spaces where that extra cache may not be beneficial for that user. And so providing something that maybe is a little bit more optimized for those other spaces as well is a better answer also. So I think there's a number of factors that go into those considerations, but as we look at it, or at least I'll say as we look at it today in the 7000 series, going vertical and stacking in a 3D dimensional way was the best way for us to accomplish the gaming uplift while preserving the package, the socket, the platform, all of those things.
Yeah, I would think, David, silicon real estate is precious, obviously, and when you can go up in that 3D plane, you gain some efficiency there for sure. You're not going out vertically. So
yep, exactly.
Or excuse me, horizontally, not vertically. Yeah, very good, very good. And on the topic of lids, actually, that you mentioned a lid there, under the lid, some overclockers and reverse engineering or re-engineering, your product is something that's kind of almost intrinsic to the community in spots. The real heavy duty enthusiasts, right? It's a passion project kind of thing for some, I guess. But some overclockers have found out that socket AM5 CPUs, if you delid them, they might actually run cooler without the IHS, the integrated heat spreader.
Yep.
Have you guys looked at that phenomenon? Any thoughts about it? Because it seems like obviously it's there for a reason. You folks built the chip and you put it there for a reason. So
I have to say the creativity and the endless curiosity from the community is fascinating. And I will say, as we look at and watch and analyze activities that delidders are doing or aftermarket lids, those types of things, we are constantly evaluating our designs, what we did in this first generation of AM5 products, and how, as we look forward to the future, we can improve those products, make them better, reduce the temperature gradient from the top of the silicon to the top of the lid where the heat gets extracted. I think there's always room for improvement. And so yes, I'll say that, we absolutely pay attention to what's happening in that enthusiast community and the activities that are going on, from extreme overclockers to delitters to custom lid makers, to look at ways that we can improve our design, ways that we can reduce that thermal gradient and make a better processor in the future.
Yeah, no, and it occurs to me too that you folks need to build this chip, obviously, for lots of other platforms, not just a DIY platform. Frankly, we're all fortunate enough to be able to build our own PCs, but they're going into OEM PCs. And so you need to accommodate lots of different platforms and form factors. And so cooling solutions come in all different shapes and sizes, and you gotta hit it right in the sweet spot. So.
Yep, indeed. But I think you're absolutely right. There are always ways to improve our designs, and I think that some of the work that the community has done has been really insightful in how they've looked at and analyzed and reverse engineered the solutions that we've done and suggested ways to make them better and better.
Yeah, kind of cool to have the community doing a little bit of engineering homework for you on the side.
I've said it before, and I mean, I think it is honestly such a gift to have a community that is so invested in the products that they spend their time and energy analyzing and improving and trying to figure out how to make this product, this processor, this platform better than it was when we created it. And I think that's that energy and excitement is really something fun to be a part of.
Nothing but goodness. Amen. All right, buddy. What else you got?
So no, actually, that's a good segue. So one of the other differences, not necessarily with just X3D, but with AM5, was that this platform is sort of designed to seek out that maximum temperature to eke out as much performance as possible. So, there was initially, some chatter when the 7000 series first launches, they run hot, this and that. But they're designed to maximize thermal capacity, based on the particular system they're in. Can you just explain why AMD did that and what the benefits are of a setup like that?
Yeah, I think that, for a number of generations now, AM4 and AM5, the way that we control temperature, voltage, power, frequency within the chips is done very dynamically. There's capabilities built into the silicon that are dynamically monitoring at many points across the chip. How it's performing, what the load is on the chip, and dynamically monitoring and modulating voltage and frequency to maximize performance in socket. And I think, philosophically, when we look at the product portfolio, those X series processors that go into our product portfolio are typically those that are designed to really, be those extreme processors, maximize performance in socket, give absolutely 100% of what a given processor can deliver in terms of performance at kind of peak power, peak temperature, peak voltage. Our 65 watt processors are kind of the opposite end of the spectrum, right? Those are really designed to be very power optimized, very energy efficient, still giving you most of maybe 80%, 85% of the maximum performance in socket at a much lower power envelope. But, it's kind of the balance between those two that, like you talked about a second ago, Dave, we have many customers who take these products. They could be enthusiast desktop builders, they could be DIYers, they could be gaming OEMs, or it could be a more traditional commercial desktop customer. And so having that range of options and building out our AM5 portfolio has been honestly one of the focus areas that we've been driving throughout the fall of last year and into the spring of this year. We kind of went from, in 2022, having just 4 AM5 processors really focused on that extreme space, to now going into CES this year in January, building that out with a set of 65 watt processors, announcing our X3D processors as well. So really getting, more to where we have a full family that represents a range of choices for lots of different types of users that might want to build an AM5 Ryzen system. And whether they're looking for energy efficiency or great performance, or need the maximum multi-thread creator performance, there's a Ryzen processor that's built for that.
Sounds like a plan.
So we're going to shift gears a little bit and go with a software question here.
Yeah.
So in the consumer space, we know gaming is, the main area where these chips show the biggest performance gain. And in that vein, is AMD working with game developers to say, hey, these chips are here, we're on our second generation now, to sort of maximize the benefits with the cache? Is there anything game developers can do to really take advantage of that really much larger cache than is traditionally available?
Yeah, it's a really good question. We are very engaged with the game development community, and that's kind of a continuum statement if you want to think about it that way. I think one of the things that we've seen is a great deal of traction with game developers on the development side of things with our Ryzen Threadripper processors, those really high core count processors to do game development, model creation, light baking, all of those things that are required in development of a game. A lot of that now happens on Ryzen Threadripper processors because of how quickly they can compile code, how quickly they can do those heavily multi-threaded tasks like rendering and light baking within a scene, those types of things. Move on to the development of a game itself. I'm sorry, beyond development of a game itself. The other thing that we do both between our Ryzen and our Radeon businesses is we work very closely with game ISVs on particular titles in their portfolio. And I think that's a case where, we'll go co-invest and co-engineer with those games or those game developers to make sure that, they're getting the most performance out of our products. They're implementing techniques that really ensure that the performance on a Ryzen processor is the best that it can be, or on a Radeon graphics card is the best that it can be. I think you see some of that in what we've done more recently at CES, the bundle that we announced with the Jedi Survivor title, Star Wars Jedi Survivor. That's a game title where we worked very closely with that game developer to maximize performance on Ryzen processors, get the most that we possibly could out of that game, and then turn that into something that we really used as a way to help end users see the benefit of that on a Ryzen processor by bundling that with our games. So we've got an entire team at AMD, both on the game alliances side as well as game engineering side, that's working with a wide variety of partners, from AAA titles to game engines to more indie titles, to make sure that we are optimizing it at every step in the game development process to make sure that performance on Ryzen is the best it can possibly be.
Awesome. And this one, this may not be something that's easily answered, but with that essentially this large pool of memory so close to the CPU, is AMD working perhaps with any other ISVs on enabling features that could take advantage of that to boost performance elsewhere? I'm thinking, say, creator or streaming workloads, or I don't know, some crazy multitasking workload where it might help to have something stored in memory so close to the CPU cores.
Yeah, Marco, I'll dodge a little bit there. Can't comment on unreleased software either, but in the creator space and in the streamer space, again, we've got a team of ISV engineers working with those partners to understand how new silicon capabilities that we bring into the portfolio can be turned into more performance or new capabilities in their applications as well. So again, that's one to watch. I think that there's a lot of exciting opportunities for how that cache can be used more and more to turn into disruptive performance in a client PC beyond just a gaming workload.
Yeah, as you get a larger install base with more SKUs here, obviously on this launch, David, your tools are going to get out into the community that much more.
Absolutely.
And you would think there's an opportunity there for, see what they do with this, what magic they can conjure up. Here comes a question from a reader, James Campbell. This is an interesting question, sort of on that line. It's just sort of thinking out of the box kind of stuff. It would be cool if there was an AI middleware where devs could optimize code for the cache. Just an idea. I guess the audience here tossing it out, but with AI on everybody's mind these days, why not? Right? I mean.
No, that's a very cool idea. AI is definitely top of mind for us as well, and I think you see that across AMD as a whole, whether it's notebooks or data center or other places, figuring out how to tap into that and use it for solving some of those problems that can be solved through an AI, automated a bit in a way or shape or form, is definitely something we're focused on.
Sure. Good stuff.
All right, I'm just gonna make a quick plea to everybody that's viewing across all the platforms. We can only see so many comments at one time, so if we missed something earlier, please feel free to add it to the chat. And if you're on LinkedIn or Twitter, we don't actually see those comments real time, so jump over to either Facebook, YouTube, or Twitch to shoot any questions over if you're on either of those platforms. So now getting back to the topic at hand, something I love to ask when we have a guest on with a really big significant launch like this is, this launch, you kind of went far and wide. Anybody in basically any country can go read a review in their language or watch a video in their language. And I know you guys internally, read and analyze as many of the reviews as you can. Is there sort of any message with this launch that you feel the tech media might have missed that you want to get directly out into the audience?
I would say that with this launch, I have been very impressed with the tech media grasping the value proposition of the product. I think buried within the reviews of the 7950X3D was a theme and an undercurrent of a lot of excitement around the 7800X3D. I think the other product in the family, the 7900X3D, is kind of that part that is, kind of right there in the middle. Great gaming performance, just like the 7950X. Really strong multi-core performance as well with 12 cores. And priced, more affordably than where the 7950X3D is. So I think that's another product that hasn't had its moment in the sun yet, but I think will, as people, really start to explore the family a little bit more.
Got it. And I'm sure we'll probably get a chance to take a look at some point in the future. But yesterday's launch was just 7950 X3D. Is the theme sort of similar with the 7900 and 7800 X3D, or is there any nuance with those CPU configurations where it behaves any different than 7950 X3D, or are we going to see improved efficiency and perf with all of them?
I think the themes of efficiency and performance are similar. Now, the biggest difference is the 7900 X3D, being a 12-core processor, is similar in construction to what we launched with the 16-core product. It's 2 CCDs, one stacked, one non-stacked. As you move to the 7800 X3D, that's more similar to the 5800 X3D. It's a single CCD product, stack cache on that CCD, so it is a little bit lower frequency. It will be a absolutely stellar product for gaming. It'll be an absolutely stellar product for power efficiency. What you will see there, though, is a little bit more separation in terms of more traditional benchmarks that measure single thread or multi-thread performance, because it's a little bit lower frequency than the 7700X counterpart that doesn't have the stack cache.
Got it.
Makes sense. Yeah.
Now, the naming of that part of the 7800X3D suggests better performance than the 7700X. Or is AMD strictly using the gaming metric to define sort of that model number on that part?
Yes, we definitely are. I think we believe that the Ryzen 7 segment is one that carries, that a lot of gamers go to as they look at a processor choice to build into their system. And so that 7800 X3D, just delivering the ultimate gaming performance in that Ryzen 7 segment, is what drove the name there. Interestingly enough, when we first announced and introduced our Ryzen 7 processors with only having the 7700X, I can't tell you how many times I got the question whether there would be a 7800X. So I'm glad we could finally, lift the veil on that one and let everybody know that we'd have an even better gaming processor in the Ryzen 7 family.
Yeah, having done this work for many, many years, when there's a gap in the naming convention, you can fully expect something is going to fill it. Yeah,
exactly.
Doesn't take a sleuth, right? Yeah, good stuff.
Right. Dave, I cut you off before. Were you going to say something?
Oh, no. Go ahead. Oh, sorry. Didn't know which Dave there. We have too many Daves.
Yeah, you would think I would clarify that. Yeah. So just one other little nuance with the 7800. Since that's a single CCD part, the 3D Vcache optimizer driver, it really isn't going to have an impact on that.
You know what? That's a great point. I should have mentioned that. You're absolutely right. It is To Windows, to any application, it is homogeneous in the way that it works, and so you don't have the asymmetric complexity in the 12 and 16 core, the Ryzen 9 parts. That does not exist with the 7800X3D. So that part is simply plug and play. Nothing an end user needs to do there except for update their BIOS, and they're ready to go.
Interesting question came in from the chat on that topic. Can the user manually tell the CPU a specific executable or game and force it onto the Vcache CCD?
That's a great question. I don't know the answer to that, but I will ask the engineer who does know the answer to that. I'm sure that there are some clever tools out there and ways to do that. But yeah, let me take that one. I'm sure that's something we can feed back through, like the Reddit community and some of the other channels that AMD uses to reach out to our enthusiasts.
Yeah, maybe that's even a switch or something you can drop in a driver at some point. I thought it was an interesting question, but
I think you can do that with the Xbox Game Bar. I don't have it in front of me, so I can't double check. But I think you can actually, the Xbox Game Bar does recognize that, and you can do it. I think I might be wrong, but I'm pretty sure that that's the case.
If you have the Xbox Game Bar in your system,
and I had a question that it just popped out of my head because I went to go look at the Xbox. Okay, it came back to me. So right now with the 7900 and 7950 X3D, it's really for best performance. And obviously, since these are gaming CPUs, Windows is where they're going to be used the vast majority of the time. But to squeeze the best performance out of these on, say, a Linux machine, you're not going to have that driver. Is AMD working with the open source community, or is there anything the open source community can do to sort of achieve the same thing and get these chips to perform well on those OSs?
Good question as well. Absolutely working with the Linux community. That is a capability that we are developing and plan on introducing into that space as well. I don't believe that's available today, but I know that that's something that's in development where we expect that to be coming soon for these processors.
Awesome.
Is that an exclusive news, or is that I don't know.
No, I don't know. Good question.
Okay. We'll take it. What else we got? Anything else there, Mark? Or
nothing else in the chat. And I know David has a hard stop in just a few minutes.
Yeah, let me maybe take a minute just to talk a little bit more broadly about AM5. I spent a week last week in Taiwan with all of the motherboard partners and really talking through plans for what we're doing in 2023. I think the thing that's really exciting for me is, our motherboard partners are really seeing the momentum that AMD has in the desktop space right now. They are very excited about what's happening. We're going to see a lot of new things coming over the next couple of months from those motherboard ODMs, expanding the range of options and price points that we cover in our AM5 ecosystem, with lower cost boards coming into the market. And then some of those other barriers like DDR5 memory pricing really coming much closer to where we are with DDR4 pricing, yet with the performance improvement that you get on DDR5 memory. And then we're also seeing a lot of partners coming with what has been, a little bit more of a hole for those Ryzen 5 and Ryzen 7 builds, which is 16 gigabyte memory kits or 2x8 gigabyte kits. We're seeing a lot of that come into market over the next month or two. And so, honestly, if we had this conversation in a couple of months closer to the May timeframe, I think the landscape for AM5 will look dramatically different, as a lot of the pieces are dropping into places that ecosystem is really gaining some momentum, growing in its maturity, and spreading out in all directions in terms of different product options, different motherboard options, and different memory options to really complete the platform.
Yeah, and it's interesting. I mean, for example, PCI Express Gen 5 SSDs are just starting to get to market now, and you guys have all those nice PCI Gen 5 lanes in there for storage, and it's really going to complete the picture nicely.
Lots to be excited about, that's for sure.
So I you know what? You just spurred another question, and I'm gonna get David in trouble here if he answers. Let me try. So that was actually this is one of the other differentiators that I should have mentioned earlier with your platform. With X670E and one of these chips, you can technically have a PCIe 5 GPU on 16 lanes and a PCIe 5 SSD for storage. Looking down the line with direct storage in games and having that additional bandwidth, have you guys seen anything internally that shows a larger benefit on your platform, say, versus the competition?
I would say nothing specifically that I'm going to talk about. So nice try, but
I tried.
I'm really, from the data I've seen, the direct storage improvements are really exciting, and that's true of Gen 4 and Gen 5 over a non-direct storage solution. I think there's something that users are really going to appreciate when they see that, and they see the speed and performance improvement that comes along with it. So I think that'll make a big difference regardless of what generation of PCI technology you're using.
Got it. Great.
Excellent stuff. Well, I think with that, we're approaching the bottom of the hour, Marco. What we get anything left, or
we are nothing in the chat? I do. So there's a private chat we have going with someone else from AMD here, and going back to that question about setting applications for the specific CCD, you can do it via the BIOS where you prefer cache or prefer frequency. Or there is also a tool in the Xbox game bar. So there are ways to do that if you want to experiment.
Cool. Excellent. Good to know.
Okay.
There we go. We learned something. I learned something.
Yeah.
That's for sure.
Cool.
Well, all right. And with that, David, thank you so much for your time. It's been a pleasure getting to meet you and kick around all the geeky goodness that is 3D V-Cache and socket AM5 and Ryzen 7000X3D. Really appreciate it. I know you're a busy guy. Appreciate you taking the time to sit with us today.
No, you bet, guys. I really appreciate you having me here and giving me the chance to talk to all the Ryzen fans out there.
There you go. David McAfee from AMD. It's been a pleasure. Folks, you can find us on the web at Hot Hardware. That's hothardware.com, twitter.com/hothardware, youtube.com/hothardware. Go figure. And you know where to find Dave. He's at amd.com, but it's been a fun-filled whirlwind week so far, and it's only Tuesday. And Dave, thanks for giving us plenty of homework this week.
You bet. Thank you, guys.
And with that, we'll bid you adieu. We'll let you off the hook, Dave. Appreciate your patience and your time. And thanks everybody for stopping by.